when this cubic polynomial x cube minus 3x square plus 3x minus 4 is divided by x square minus 3x plus 2. So we are just trying to find remainder. Okay, to find the remainder for these type of problems we have different methods. As per the requirement, as per the comfort, we need to proceed, we need to choose the method. But just I am giving you all the different methods. I have 4 methods now to solve this problem. I have 4 different ways to find the remainder in this situation. I will discuss all those 4 methods, and among those we need to learn all those 4, and among those 4 we will choose appropriate method depending on the problem in different situations. But as an introductory problem, see, as a first problem, I will mention you here all the 4 methods, right? So in the previous classes of these polynomials, we already learnt about the division of polynomials, division algorithm of polynomials, Harner's process, synthetic division of polynomials, remainder theorem and factor theorem of polynomials. Using all these concepts, I have 4 different methods to find a remainder, and one by one I will move. The first one is very traditional one, and which is usual division. So if you are trying to find the remainder when this is divided by that, as a first method you just go with usual division. So this x cube minus 3x square plus 3x minus 4 is dividend polynomial, and we are going to divide that dividend polynomial with the given divisor polynomial x square minus 3x plus 2. So it's a usual traditional way. Okay, so actually I mentioned you here only cubic polynomial as dividend. Since it is a cubic polynomial, all these 4 methods will looks like comfortable. Whereas if the degree of this dividend polynomial is somewhat more and more, then in that situation you need to choose appropriate method depending on the degree of dividend as well as the degree of divisor. Okay, but first of all you need to learn all the 4 methods. So usual division, I think we are all very familiar with this. Yeah, this first term is x cube, this first term is x square. Divide this first term x cube with this x square, you will get x. Write that x in this quotient part, and then x into x square is x cube, x into minus 3x minus 3x square, x into 2 is plus 2x. And then do usual subtraction. So what will happen? Minus plus minus. See, x cube minus x cube gets cancelled. Minus 3x square plus 3x square gets cancelled. We left with 3x minus 2x is x minus 4. So it's x minus 4. When you observe, see the degree of this x minus 4 is 1, which is less than degree of this divisor x square. It is 2 and it is of degree 1. So there is the division process, and this x minus 4 is directly our remainder. Since my task is to find the remainder, first method is very clear. There is the situation. This is first method. Okay. So when you observe, this is third degree and this is second degree. So usually it needs 1 or 2 steps to find the remainder. So it is very clear, right? As I mentioned you, if the degree of this dividend is somewhat more, then this division process becomes complicated. In that case, we need to use any other method. Okay. So now I am giving you method 2, where I will use division algorithm to find the remainder. Okay. Method 1 is clear. Our remainder is x minus 4. Now I am discussing method 2. In this method, see, this is dividend. From the question it is clear. This is divisor. So you just let the remainder as r of x is equals to, since it is of second degree, then the remainder is of first degree. Okay, is of the format ax plus b. So first, suppose if this is dividend and that is divisor, we don't know about quotient, we are trying to find remainder ax plus b. So by combining all these things using the statement of division algorithm, we will write like this. Okay, dividend x cube minus 3x square plus 3x minus 4. Dividend is equals to divisor x square minus 3x plus 2 into quotient polynomial plus remainder polynomial by the statement of division algorithm. I will rewrite it like this. This is equals to this x square minus 3x plus 2 is simply nothing but x minus 1 into x minus 2, is it right, into q of x plus the remainder as we consider it is ax plus b. Now at the end what I have, this dividend x cube minus 3x square plus 3x minus 4 is equals to x minus 1 into x minus 2 into q of x plus ax plus b. My target is to find remainder. That in the sense I need to find the values of a and b so that I will conclude that my remainder is of ax plus b. To find that you just take x, see you don't know quotient, right, you just eliminate it. So how can we proceed? I will move in such a way, just have a look. Yeah, for the space actually I will erase this part, okay. This division and method 1 is very clear, I think so. So we need to go with the method 2, right. So finally what we have, x cube minus 3x square plus 3x minus 4 is equals to x minus 1 into x minus 2 into q of x plus ax plus b. So this is from the statement of division algorithm. That is the sense which is true for all the values of x. I need to find a and b. I don't know quotient. So to neglect to eliminate this quotient, you just think about these two factors. So you just take x is equals to 1. Okay. Why we are taking x is equals to 1? If we take x is equals to 1, see there is a chance to diminish this q of x, to eliminate that q of x. So take x is equals to 1. So when you replace x1 here, what you will get? That implies, yeah, I will write directly, 1 cube minus 3 into 1 square plus 3 into 1 minus 4 is this left side part. And since we are replacing x is equals to x with 1, when you replace 1 here, 1 minus 1 is 0, 0 into anything is 0, this part is 0, and directly I will write that this is a into 1 plus b, and that implies a plus b is equals to, when you simplify, minus 3 plus 3 will get cancelled, 1 minus 4 is minus 3, a plus b is equals to minus 3. So if you take x is equals to 1, you will get that a plus b is equals to minus 3. And the next thing is take x is equals to 2. Why? Because if you take x is equals to, again this is 0 and q of x, when you multiply it with this q of x, this total term will become 0. Okay. So take x is equals to 2. If you take x is equals to 2, what will happen? 2 cube minus 3 into 2 square plus 3 into 2 minus 4 is equals to, so this part will become 0 plus a into 2 plus b. So a into 2 plus b is what? 2a plus b. So 2a plus b is equals to, yeah, we need to simplify this. 2 cube is 8, okay, 3 into 2 is 6, 8 plus 6 is 14, minus 4 is 10, and still we have this term. 2 square is 4 3 is 12, 10 minus 12 which is minus 2. So a plus b is equals to minus 3, as well 2a plus b is equals to minus 2. So using these two we need to find out the values of a and b. So just think about it, directly I will do. When you subtract first equation from the second equation, b and b gets eliminated, gets cancelled, 2a minus a is a, and we are subtracted, okay, minus 2 minus of minus 3 is plus 3. So from these two it is very clear that when you solve, you will get that a is equals to 1. Okay. Whenever a is equals to 1, what you say about the value of b? Replace a 1 in any one of these equations, you will get that b is equals to minus 4. So a is equals to 1 and b is equals to minus 4. Finally, what to conclude about the remainder? So the remainder r of x is equals to, as I consider, this is ax plus b. Okay, we started with that. So replace a with 1, b with minus 4, you will get it as x minus 4. Finally, the remainder is what? X minus 4. First method we just completed using regular division process, whereas in second method we used the process of division algorithm, and by the division algorithm again our remainder is x minus 4. Okay, I have method 3 and method 4. In method 3 I will use synthetic division. In method 4 I will use synthetic division for quadratic factor. Okay, I will discuss one by one. First of all, you just have a look. Now method 3. Method 1 is by division, method 2 is by division algorithm statement, and method 3 is just by using Horner's process or synthetic division for linear factors. As per the problem, dividend is this x cube minus 3x square plus 3x minus 4, and divisor is that x square minus 3x plus 2, which can be factorized into the linear factors as x minus 1 into x minus 2. So now what I do is I will do Horner's synthetic division for the linear factors. First of all, you just identify the coefficients of the dividend polynomial. 1, minus 3, 3 and 1 minus 4. These are the coefficients of the dividend. So since as a divisor x minus 1 and x minus 2 are the linear factors, so first of all you just do this Horner's process with 1. So take 1 here. So as a process we need to start with 0 here. So 1 plus 0 is 1. 1 into 1 is 1. Minus 3 plus 1 is minus 2. Minus 2 into 1 is again minus 2. And here 3 minus 2 is 1. And again 1 into 1 is 1. Minus 4 plus 1 is minus 3. Okay. And this minus 3 is the remainder. So already I mentioned you, okay. Already in the previous classes we discussed about the way of Horner's process. Now this is dividend polynomial. And since we are discussing this x minus 1 as a factor, so you just write 1 here. So 0, 1 plus 0 is 1, and then we did it like that. So whenever you divide this polynomial with this x1, this is x minus 1, this minus 3 is the remainder as well. This part is the quotient actually. 1 minus 2, 1 is the quotient. So this step of synthetic division, Horner's process, what explains us is this dividend x cube minus 3x square plus 3x minus 4 is equals to divisor x minus 1 into quotient. It will represent as a quotient. Okay. So what is the quotient? X square minus 2x plus 1. X square minus 2x plus 1. And this minus 3 is the remainder. You just write here it is minus 3. So now this x square minus 2x plus 1 is simply x minus 1 whole square. We know it, okay? No. What, is there anything wrong? Okay. X minus 1 whole square, we know it, okay? But since we are trying to use this Horner's process, just I am moving with the same procedure, okay? And now this time you just do Horner's process for this 1 minus 2 1 with the second linear factor x minus 2. Take 2 here, 0. 1 plus 0 is 1. 1 into 2 is 2. Minus 2 plus 2, 0. 0 into 2, 0. 1 plus 0, 1. And this time, this 1 is what? Remainder. When you divide this 1 minus 2, 1 with this x minus 2, and this 1 plus 0 will become like a quotient. So, we have a chance. This is equals to x minus 1 into the x square minus 2x plus 1 can be written as this divisor x minus 2 into, just I will use another color, okay. Now for the second step of division process, synthetic division process, this x square minus 2x plus 1 works like dividend, and we are dividing it with x minus 2, and the quotient obtained is this 1 and 0, which is x plus 0. So x is the quotient, whereas the remainder obtained is 1. Already we have minus 3 as the remainder of the previous case. So this red color part just indicates the second step of Horner's process. And now this is equals to, and just you multiply x minus 1 into x minus 2 into x, and then x minus 1 into 1, and then minus 3. So now this is equals to x minus 1 into x minus 2 is simply nothing but x square minus 3x plus 2 into some x plus this part is what? X minus 4. When you observe, this dividend is equals to this divisor into quotient plus remainder. Again we found that the remainder as x minus 4. Just I am discussing all the 4 methods with a simple problem. Okay. Method 1 is usual division. Method 2 is division algorithm. Method 3 is Harner's process for linear factor. And then method 4, Harner's process of quadratic factor. Okay. Have a look. So method 4, Harner's process for quadratic factor. That in the sense directly we need to use this quadratic factor instead of this x minus 1 into x minus 2 in Harner's process. Why we need that Harner's process for quadratic factor? See, actually for the same problem I am discussing all the 4 methods. But for suppose if there is a problem whose divisor can't be factorized like this. For suppose if I have any divisor of this format like x square plus x plus, you may say some 2, x square plus x plus 2. Do we have any factorization for that x square plus x plus 2 like this linear factors? No. Then for those type of divisors, that method 3 is not applicable. We need to go with method 4 only. Okay, but just as a problem, for the same problem I am discussing all 4 methods, and that's why I am using Harner's process for quadratic factor also for the same problem. But since I mentioned for quadratic factor, I need to consider this quadratic factor x square minus 3x plus 2. So as we discussed in the previous classes, the way of finding remainder and quotient using Harner's process of quadratic factor. First of all, list out those 1, minus 3, 3 and minus 4. Then we need to compare the divisor with what? As a process, we need to compare the divisor with x square minus ax minus b as we discussed in the procedure. Okay, you just compare those two. A value is 3. Compare those two, you will get b value as minus 2. And then as I mentioned you need to replace these 3 positions as zeros along with this position also. Now you just proceed with the Harner's process. Add column wise, that is 1. 1 into 3, that is 3. Add column wise, that is 0. Then these two places can be filled by 0 into 3 as 0 and then 1 into minus 2 which is minus 2. Add it 1. So as I mentioned you, last 2 positions indicates what? Remainder. Okay. This is 1. So 1 into 3 is not allowed because that 1 comes under the remainder. So use 0 there. And then this 0 into minus 2. This 0 into minus 2 is again 0. So add column wise, you will get minus 4. So since it is 1 and minus 4, it will directly represent that remainder as x minus 4. Okay. So if you have any confusion related to this Harner's process of quadratic factor, you just revise the previous classes where I discussed that Harner's process. Okay. So this is method 4 and at the end we have remainder. See, once again you just look at the problem. The problem is very simple. We need to find the remainder when this polynomial is divided by x square minus 3x plus 2. To find the remainder we have different procedures. Division algorithm, Harner's process of linear factor, Harner's process of quadratic factor. Just I explained 4 methods for the same problem, but depending on the problem we need to choose appropriate method. First method, division method, see we usually don't go with the division method. Okay. Whereas the second method, division algorithm. Sometimes division algorithm is very helpful to find the remainder. But that second method only gives us remainder. Just observe it. Second method only gives us remainder. But second method won't give us quotient because we are neglecting quotient and we are finding remainder. If the question asks you only to find remainder, second method is okay, no problem. But sometimes the question asks us to find quotient along with remainder. Then in that case, second method is also not applicable. Don't go with second method. Either you move with third method or fourth method. What happens with the third method? See, third method is very comfortable if the divisor has linear factors. If we are able to factorize it, you just go with the third method. And for some problems, the divisor has no linear factors. We have no chance to factorize it. So third method is not applicable. Then in that case, you again come and think about this fourth method. Sometimes third method, first method and fourth method. See, second, third and fourth. Second, third and fourth, these three methods becomes bit complicated and not possible to solve the problem using these three. Then we have no other way, just go with the traditional way, and that is what? Division. That division solves every problem, but maybe lengthy sometimes. Okay, so that's it. Okay, just have a look. We have four methods. According to the situation, we need to choose appropriate method and then we will solve the problem. Have a look.